Anish is
Yes,
also our own MTech student. I don't know which campus are you studying?
no, sir. I am from College of Engineering, Trivandrum.
Okay, College of Engineering. Very good. You are
Engineering,
welcome.
Trivandrum.
Yeah, you
Yes,
are
sir.
welcome. You please make your presentation.
Yes,
Your
sir.
first one.
Shall I share the screen? Yes. Sir, I hope the screen is visible.
Yeah, it is. It is visible. Please go ahead.
Okay. Okay.
Try to
So,
summarize in 5 minutes.
yes, yes. So, myself, Anish Rajendran, I'm currently doing PG in MTech in Power Systems Engineering, which is coming under Department of Electrical Engineering at College of Engineering, Trivandrum. So, we did this work as part of my thesis work, which is jointly with Energy Management Center, Kerala. This topic is all about optimal placement of electric vehicle charging stations. So we know that our government, both the central government and the state government, is giving a great push to electric vehicle and e-mobility promotion, which is great support to sustainable ecosystem. We know that the pollution caused by transportation, which accounts for almost 70% of the global pollution, which we can offset to a great extent relying to green energy sources from solar and wind, and this can be used for electric vehicles. So this we have launched the national e-mobility program and FAME 2 scheme in 2019, and it is projected about 10 lakhs e-scooters, 5 lakhs of e-autos, and 50,000 e-cars by the end of 2020. So the governments have started working on that. So this further development of this e-mobility, we need a very keen charging infrastructure, which will supply just like the fuel stations we are having the spread of Kerala state. We need to expand more charging outlets to fuel these electric vehicles. So along with this, we have found a problem, which is basically optimization problem. So coming to the problem formation, we have identified the Kerala State Highway stretch from Thiruvananthapuram to Kasaragod. So you can see the map. So here we have identified the strategic locations where EV charging stations can be placed. So here the prominent candidate, these are called nodes. So the candidate nodes are fuel stations, which one dispenser can be changed to fuel station, EV charging station. Then the restaurants where parking time is available for consumers while traveling. Since in EV, the main problem which the consumers are facing is the range. The extension of range to a further extent without sizing the battery is not, say, bigger constraints. So we have to place the EV charging stations suitably to extend the range of the vehicles. So we have shopping malls, supermarkets. Then the KACB substation also we have taken because as per the state government plan, some of the KACB substations also identified to because the KACB is the largest electrical utility in Kerala, who is also the nodal agency to implement the charging infrastructure in Kerala. So some of their substations are also taken care into consideration. Then we have identified the availability of the number of nodes available. So the most we have identified that 73% of the fuel stations are available along the highway, and the second largest contribution is from the restaurants. So based on the wait time and number of slot availability, such constraints, we prioritize these nodes, and we have identified district-wise nodes and identified that we have a total number of nodes maximum in Alappuzha, and second highest is in Malappuram and Thiruvananthapuram. So a total number of 217 candidates are identified. Now coming to the statistics, we have prepared the statistics like that, and we found that the fuel stations are the most prominent share in the number. So we have formulated the problem by minimizing the capital cost and minimizing the operating cost. And also this is a combined transportation plus power system problem. So we have minimized the power loss in the grid, and we have minimized the wait time. So we have identified the constraints like the charging demand points and the energy cost limits, the active and reactive power limits of the grid, So some equality constraints, like this is the most important equality constraint. The load generation balance has to be met by placing these charging stations on required buses of the power system. So we can see this is the we have superimposed. This is the Kerala map. The red line is showing from Tirunelveli to Kasaragod, which you see in this line where the candidates are placed. So this map is merged with the superimposed with the electrical power system network. So we have selected a standard 33 bus IEEE system for this study. So we have superimposed this, and we have used the genetic algorithm based optimization technique to optimize the problem further. And we have used the forward reverse load flow analysis. Since this is a radial network, we have used this forward reverse algorithm, and we have used this MATLAB program, which is inbuilt genetic algorithm is available, and we optimize the results, and the best particle best and the mutation was done. And we have identified the one study with minimizing the number. We are still in the work is not completed. We are doing this on a
Sir, time is getting exceeded. Can you
yes, yes,
conclude?
1 minute more. Yeah. So we have optimized the numbers, the number of fast charging stations and slow charging stations, and which node number these are placed. So these are placed like that, and the capital cost and operating cost also optimized. So these are the node-wise operating cost and capital cost, and the total cost was arrived, which is the optimized cost for the utilities. Then coming to the conclusion, the major share of the cost is the capital cost, because nowadays the cost of the charging station is on a higher end. It is tend to reduce. Now the second is the energy cost, which is the capital, which is the the operating cost. Then as a conclusion, we need a optimal placement of the EV charging stations to the utility grid as well as the transportation network, which will reduce the power demands, and which will reduce the losses in the system. So this will add to a sustainable development of the community. So thank you.
Yeah, thank you, Mr. Anish. It was a very good presentation. One or two very small questions are coming in my mind. One is how much time it requires to charge, and if it's taking more time, then parking of the vehicle will be a major issue. Can we have a device wherein the battery is just replaced with the charged battery? This charged battery is immediately replaced by a charged battery. Some system has to be worked out on that, so that we reduce on this time of charging plus dead parking. So that, I think, that level of efficiency needs to be brought in. I'm sorry, I'm not an expert on this, but this is just offbeat. I'm just raising this question. Are there some other
Yes,
questions,
yes.
please?
Yes, sir. Actually, what you are told is correct. We have not considered the battery swapping in this. So we are
Yeah.
further developing this, and also we are planning to implement the use of machine learning and artificial intelligence. So that that's why I attended this seminar. We have a workshop on that also. So if time permits, we will incorporate that also.
Okay, fine. Thank you. Are there some other questions? Some
Yeah,
quick questions? Answer?
This is an excellent presentation, very good presentation, very good analysis also. My only question is what traffic density and what percentage of electric vehicles did you consider in your analysis?
Actually, we have taken the data from our motor vehicles department, which is available in the Parivahan portal. Almost 20% of this total vehicles, which is projected in 2020, this requirement is projected, but it is not met. So we have taken almost 25%, 20 to 25%, I think, yeah, 25% of this total number. And we have taken the 217 numbers of candidate nodes, which where we can place. These are only the candidates. Not necessary that we have to place everywhere. There are some critical nodes where placement has to be done. So that critical nodes plus some other nodes will be coming. So we are expecting around 150 numbers, because the state government is planning to put 150 numbers of charging stations. So we are concentrating on that, sir.
Okay. Okay. Thank you.
Okay. Thank you. Thank you, Mr. Rajendran.